Okay, so for the second half of this workshop, we're going to be looking at data manipulation using the dplyr package, and that's really the central package in the tidyverse for manipulating data. So given a set of data that's already in a data frame, how do we manipulate it to extract the features of the data that we may want to look at? And it does so by basically building upon 6 main functions. So there's there's 5 functions that do different things, and one that allows you to do those things on subgroups of the data simultaneously. And many of the processes that we'll need to do to extract information from data can be done using combinations of those 5 main functions along with the group by facility. So we're going to be looking at a set of data on school students at New Zealand schools. And so if we run this code block to read the data in, we can see that we have 66,261 rows, and each row represents a school, an ethnic group, and a year level combination. And then we have the number of students of that that fit in that particular category. So if we added up the students column, we would get the total number of students across all schools in New Zealand in 2023, which is where the data were from. So for each school we have multiple rows, obviously, because there are multiple ethnic groups and multiple year levels. So all up, I think there's 15 different year levels possible. So there's year 1, which is when kids start at primary school in New Zealand typically, up to year 13, which is when most folk leave school. But there's also a year 14 and 15 as well. So there's 15 different categories for year level, and then I think there's either 6 or 7 different categories for ethnic group. So each school could have over 100 possibilities for ethnic group and level, the product of 7 and 15. Most of them are fewer than that because you've got schools that are only primary schools, so they only go up to year 6. And you've got schools that are only secondary schools, they go from year 9 to 13 typically, and you've got schools that are intermediate schools, and that's just year 7 and 8. So we're going to start by looking at the filter command, which is used to select rows, right? So instead of having all 66,261 rows, perhaps we only want the rows where the ethnic group is Māori. And so you can see that there's around 17,000 rows that correspond to that ethnic group, right? Now, just a note that obviously the word Māori contains a macron on the A, so a diacritic, if you like, on the A, and this can potentially be a bit tricky to do on your keyboard, which is mostly designed for typing sort of Latin characters, right? So English characters. Depending on where you're from, of course, some of you may well have keyboards that are set up to type some other language by default, right? So how do we get this macron on the A? Well, it depends on the computer you have. Basically, if you happen to have a Macintosh, an Apple Mac, then I think you just hold down the letter A on your keyboard, and it will pop up with a little box that allows you to select which macron you want, or which diacritic you want. So that's how you do it. One method that works across machines, so across all computers, is copy and paste, right? So I could, for example, just highlight Māori there and just copy it, and then just paste it in down there, and I've got the correct macron. So copy and paste is an easy way to do it, and one way to ensure that you do that reliably is to copy and paste from the data. And so sometimes, in this case, we've got the thing we want to copy and paste in the data frame directly, whereas we don't have it when we just type the name of the data frame, because the top 10 rows or so don't have it, and it might take a wee while for us looking through it before we find one. In this case, not too long, it was only 3 pages, but in a very large data set, finding the thing that you want might take a while. Another thing you may want to do is just find out what entries are there in the ethnic group column. Okay, and both of those problems can be solved with the same idea, and that's using count. So the count function is one of the helper functions in dplyr that combines some of the functions some of those main functions. So what the count is doing is it's doing a group by and then it's doing a summarize in order to figure out how many rows there are of the ethnic group. So if I run that, I notice that there are 7 entries in the ethnic group. There they are, and this is how many rows of each one there is. So this is the 16,798 is the number of rows we had when we filtered by Māori. So the advantage of this is it tells you how many there are. It tells you what they are, which is nice. We can see that there's an other category, there's a MELA category, there's an international fee paying category, which is something that you wouldn't have thought would be an ethnicity. So this is obviously how they put folk that are coming to New Zealand to study, and because they are not New Zealand residents, then they are, they are undertaking their education with a different fee structure, if you like. So the advantage of this is now we've only got, we've got the entries and we can copy and paste easily, right? So if I copy and paste that Māori entry, then I get it right. Even if the word doesn't contain macrons, you'll see that the spelling of the words is important, right? So if we wanted to just find the international fee paying students, right, we could use the same code that we used up here and just type international fee paying inside of here, but we'd have to remember that the I of international fee paying has a capital, but the F and the P do not, right? So copying and pasting it is a way to make sure that or to lessen the ability to make typos, right? Okay, what else can we do with filter? Right, so these two are combining, filtering by the combination of two things. So this first one here is identifying data in the role data frame, which is our 66,000 rows, where the ethnic group is Māori and the level is year 1. Right, so this first one is providing only the rows where the ethnic group is Māori and the year is 1. So this would be new entrants, if you like, or 5-year-olds or 5 or 6-year-olds, I guess, at the various schools that have identified as being Māori. The second one here is slightly different in that instead of a comma, the comma essentially means and that both of these filters are applied at the same time. The vertical bar here, which is usually just above the enter key on your keyboard, that's an OR. Right, so this is filtering the row and filtering the role data and finding rows where the ethnic group is Māori or the level is year 1. Right, so here you can see that we have more rows. So we don't have all the rows, obviously. We started with 66,000, now we've only got about 22,000. So we've got about a third of the rows, and each of the rows either has ethnic group being equal to Māori or the year level is 1 or both. Right? And so here you can see that this first row is returned because the year level was 1, so was the second row. The third through 6th row didn't have the year level 1, but were ethnic group Māori, so that's why they were returned, and so on. Right? Obviously, there's going to be some where we have both criteria satisfied simultaneously. Let me see if I can find one. Well, we know they exist from the first example, don't we? There's one there. Right, so Abbotsford School, Māori year 1. So of course that gets returned. Right, so this or is not an exclusive or. It means or and, if you like. Right, so both of these criteria can be satisfied at the same time or just one of them. Okay. So a helper function for one of these options is the in operator. So often, so this first set of code here. We want to find the rows where the year level is 1, 2, 3, or 4. So we've used the bars there to do OR. That gets a bit tiresome, and so a way to do it in sort of less typing, if you like, is to utilize the in operator. So the in operator is just saying is level one of the options given in the following vector of options, list of options, if you like. The C function is a classic function in R to just combine things together. So it's short for concatenate or combine. Okay. And so that basically just puts those year 1, year 2, year 3, year 4 character strings together and operates as a unit, right? So this is just saying, is the level in either of these options, right? So these two will give you, of course, identical results, but the code for the second one is a little bit more readable. So let's do some examples. Find all rows corresponding to Queen Elizabeth College students in Year 9. So Queen Elizabeth College, or QIC, is a college here in Palmerston North. So we're going to want the school. All right, that's the column that would have our school in it. And we want Queen Elizabeth College. All right, so I'll run that just to see how we go. There we go, we've hit them all. So there's the 17 rows returned for Queen Elizabeth College. And we only want Year 9 students. So we also want the level to be Year 9. There we go. So all up, we can see there are 61 students in Year 9 at Queen Elizabeth College, or QEC, here in Palmerston North. What about this next one? Find all rows where there are more than 100 Year 9 Asian students. So again, it's a filter because we're finding rows. So we're going to want the ethnic group to be equal to Asian. So I'll run that to make sure I've got that correct. Yes, we've got 11,000. That seems about right. We also want the year level to be 9. So we want Year 9. So let's just check our data frame there. Yes, we've got Year 9. And now we want only the rows where the students is more than 100. So to do more than, it's just greater than 100. Okay. Now, one thing to note is I'm using double equals here for is equal to. Is it equal to, right? We use single equals for passing parameters to things, right? So way back up when we were doing our ggplot stuff, right, we were using a single equals here to pass in parameters. So the single equals is assign it equal to, so that's an assignment operator, whereas the double equals is it equal to, that's a comparison operator. Okay, and in this case we're using a greater than operator. There's also less than, there's greater than or equal to, and so on, right? So here we go. These are the schools that have more than 100 students, more than 100 Asian students in Year 9. Which of course are going to be all the bigger schools, aren't they? Find all rows where the school name starts with the letter G. Okay, so we've got a wee hint there. So we're going to be looking at the school, and so it suggests that we might be able to go school greater than G. And so this will give us all the schools that start with the letter more than G. So it's doing a string comparison here. And if we go far enough through this list, well, so this is up to, we've got 54,000 rows. It's all the way up to Glenorchy School. If we went even further than that, we'd find schools that also start with H, because of course that would still satisfy this expression. So we would need something like this to give us just the G schools. Right, so the school starts with something more than G and finishes with something less than H, and starts with something less than H. Right, that'll guarantee it starts with G. Another way, which is perhaps a little bit more readable, is to use some helpers. So the stringr package, which is included in the tidyverse, contains a whole bunch of helpers for dealing with character strings, or labels, I guess. And so the starts function is one of them, and so you just say the school has to start with G. Okay, and that'll give the same rows. Okay, so okay, notice I've used double quotes here, I use single quotes there, that doesn't matter. Okay, as long as you're consistent, i.e. you start with one and end with the same one, everything is fine. Okay, so there's no difference between single quotes and double quotes, like there might be in some other languages. Okay, so that's filtering data, which is picking rows out. We can also arrange the rows or sort the rows using the arrange function. So for example, let's have a look at what these ones are doing. This first one is arranging the role data first by ethnic group. Right, so the ethnic group is going to be arranged alphabetically. And then within the ethnic group, it's going to be arranging by level. So first arranged by ethnic group and then arranged by level. Okay. The second one is arranging the role data by descending students column. Right, so if I run that, you'll see that the first row is the one that has the most students in a particular category. So this here, Te Ahu or Te Kurapunamu, is the correspondence school, New Zealand Correspondence School, which of course has many, many students from all over the country that are doing their school by correspondence. And so it's a very large school as a consequence, and therefore tends to appear in the highest number of students. Some other colleges are also very big though, right? So this is in this college here is Hagley College and I think Christchurch. Right, so let's have a go at some of these. Arrange the roll rows by the number of students. Well, this is just the opposite of this, isn't it? So instead of going descending, we'll just go ascending, which is the default. All right. So this is going to be all the ones with only one student of a particular category. What about this next one? Find all rows where the ethnicity is specific, arranging them by decreasing number of students. So this is a combination, right? So first of all, we have to find rows where the ethnicity is specific. So we don't care about any of the other rows, so that would be a filter, right? So step one. So we're going to go filter the role data such that the ethnic group is specific. Okay, and now we want to arrange it. So what we could do is we could save the output from the filter step into a new variable, a new data frame, with an assignment. So I've used equals. You could also use the wee arrow if you want. All right, so the wee arrow made with the less than sign and the minus or dash does the same thing. And you can see now I've got a new data frame here. Notice it doesn't spit anything out. So an assignment like this won't print it. Whereas just running the filter by itself produce the output, and the default thing that R does when it produces output is print it, right? But when we assign that output to a variable, then there's nothing left to print because the result of that function is the creation of that variable Pacific. Okay, so of course the Pacific data, which we could then print if we wanted to, has those rows, right? And now we can then arrange that data, right? So we could then arrange the Pacific data by, what do we want? Descending students. So there we go. So we can see that there's 289 students at Kedgley Intermediate School in Year 7 that are Pacific. Okay. So this is the first way we could do it. So this is use a temporary data frame or variable. Option 2 is we could do the same thing without the temporary variable. Right, so we could do the same code. We could first do our filter, and then we could do our arrange by just passing that in to the arrange, right? So here's our code for the arrange, right? And our Pacific variable was the filter, so we could get the filter stuff and just put it in place of the Pacific. Okay, so this does it all in one step. Okay, Now the problem with this code is it's a little bit hard to read, right? I think you'll agree that this this sort of two-step process is probably easier to read and understand what's happening than this one, largely because you kind of have to read this one inside out, right? To figure out what this is doing, the arrange step is actually the last thing that happens. The first thing that happens is we grab the role data. Then we filter it using the ethnic group as specific. Then we arrange using the descending number of students. So this parameter here applies to this function, the arrange function, whereas this parameter here applies to the filter, right? So it's sort of read inside out, which is a bit messy. We'll see how we can improve this in just a moment. And then the next one, which school has the highest number of international fee-paying students at year level, at year 13? So again, this is a combination of filter, because we only want international fee-paying students, and we only want year 13, and then arrange in order to find the biggest, right? So we're going to do year 13 internationals is going to be take the role data and filter it. Well, I guess we could do it in multiple steps, couldn't we? So we could go take the role data and filter it and just grab out the international fee paying. Alright, so that's int international, it's going to be that. And then we could filter that further to get the year 13s. And then we could arrange it. Descending number of students. All right, so we can see that the UP International College of New Zealand is the one that has 71 international fee-paying students in year 13. Okay, fewer steps might be to notice that we're doing two filters. We could do them both at once. So we could go straight to this one by a single filter where we go to the ethnic group is the international fee paying, and the level is year 13, right? So we get that data frame straight away, and then we could do the arranging. And then inside out, all right, we could just do it in one line of code. It's going to look a little bit messy. All right, but it gives us the same answer. Now, you could try and tidy this up by sort of doing some code formatting, I guess. Something like this. Maybe. But I don't think it really helps much, right? Still, you know, reading this, you've got to read it backwards. You start with the role data, and then you filter it with these two things applying to the filter function. And then after that, you arrange it with this thing applying to the range function, right? So it's inside out. So we solve this sort of inside out behavior by using the pipe operator. So the pipe operator is basically it's a way to take a object and apply an operation to it, returning an object from that. So here's the code that we had before, right? Or like this, same thing, okay? That can be replaced by this code down here. Okay, so this pipe operator, which is put in using the key code Control Shift M on a Windows machine or Command Shift M on a Mac. Okay, then it puts those characters in for you, or you can just type them out by hand if you want to. Okay, what this does is it takes the thing on the left and inserts it as the first parameter of the function on the right. So this is going to take the role data and insert it as the first parameter to the filter function. And of course we know that filter as its first argument, first parameter, is the data frame you want to filter. So this is taking the data frame and then putting it into the filter and filtering it by ethnic group. We then pipe the result of that, so the result of the filter then goes as the first argument to the second filter. So we then filter by year level, and then the result of that, which will be the role data filtered by ethnic group and level, then gets passed into the first argument of the arrange. So this setup here is in fact translating it, so it translates with the R parser down to this version here. Okay. So it's doing exactly the same thing, it's just way more readable, right? So when we run that, we get the exact same answer, but of course this is much more readable. We can read from left to right, right? We start with the role data, we filter it. How do we filter it? Well, we want the ethnic group being equal to international fee paying. We then filter it again to get our year 13 students, and then we arrange the result. So all of the data wrangling that we'll be doing from now on will be done using the pipe, because it's just so much more readable, right? It's you know, I can come back to this and sort of immediately understand what's happening, whereas if I come back to this, I have to sort of look at it for quite a long time to figure out that that it starts with the role, then it does two filters, then an arrange, right? I'm reading it all backwards, and it's hard to figure out what each of the parameters, which function each of the parameters line up with. Okay, so we might want to do the Pacific one. So what was the Pacific one? Let's remind ourselves. Find all rows where the ethnicity is Pacific, arranging them by decreasing number of students. Let's redo that one. So right, so we take our role data, we filter it such that the ethnic group is Pacific, and then we arrange by descending. Oh, and a couple of other things I should note while I'm doing this is that how I do this in practice is as I'm typing my pipeline. So once I figure out, you know, the steps to do, as I'm typing it, I run it, right? So type the name of the data frame, run it to make sure that I'm getting what I expect. So is this the right data frame to be using? This is particularly important when you get lots of them. So the disadvantage of using these intermediate data sets, which of course we don't have to use when we're using the pipe, the disadvantage of it is now I've got a whole heap, and in fact I've repeated them, right? Because at one point I used international, and at another point I used internationals. Now we know that these are actually the same. They were generated with essentially the same code, but potentially they might not be, right? One of them might have fewer rows than another because I made a mistake or whatever, and then which is which, right? So doing the name of the data frame and checking it is what it is. So for example, check I've got the columns I want and the number of rows is about right. That sort of thing is useful. Then I do the pipe and I do my next sort of operation, right? So I'm filtering by ethnic group. Just a note on this as well, another advantage of the pipe is that I get auto-completion. So if I just start typing ethnic group, I get this wee pop-up because the editor here is smart enough to look inside the role data and find the column names and then suggest possibilities for completion. So this helps with potentially typos, right? So even if I'd used a lowercase e there, it would have still popped that up and I can just click on it or press the tab key on my keyboard and it will get the spelling right for me. That only happens if you're doing a pipe, right? Because at that point it has the context, right? It sees the pipe and goes, I've got context. What's been fed in here? Can I use that to sort of help the person out? It's a little bit of AI, isn't it, really? AI being a generic term for any useful thing nowadays. Sorry, that was a bit of a cynicism. Right. ethnic group is specific. Oh, I've messed that up, right? Of course, it's supposed to be double equals, right? So again, now I can check. I've got far fewer rows. It looks as though they're all ethnic group specific, probably working, right? And then arrange by descending number of students. There we go. Okay, and that's the answer, of course, I got last time. All right. So that's the pipe, filter, and arrange. For choosing columns, we use select. So select picks out which columns you want, and you just specify the columns that you want by name. Again, autocomplete works here. If you don't want a column, then you just put a minus in front of it to get rid of it. So for example, so this first row is going to be selecting just the school, ethnic group, and students columns. So that's going to be dropping the level column that we had before. The second row is doing two things. Second line of code here, it's dropping the school column, and it's picking out the students column, but it's renaming it to number. So here I've got a new column called number. For some reason it's truncated it in the display here, but it is number. Okay, and we've dropped the school column with the minus. And this next one is pulling out the students column, then the level column, and then everything else. So the everything operator is a function from tidy select for picking everything else basically that I haven't got so far. So you can see here that essentially this is moving or rearranging the columns. Right, so the students column is now on the far left, then the level column, and so on. This is particularly handy if you've got sort of hundreds of columns or even tens of columns, too many columns to show in the sort of default output, and you just want to look at one of them, right? So often one of the columns you're interested in might be sort of the 12th column or something. And so by doing a select with that column and then everything, you can just pull it to the left in order to have a quick nosy at it. Okay. So let's do these exercises here. Rearrange the role data so that students and level are first. Well, that's what we've just done above, haven't we? That's the same thing. Easy. Okay. Rename the school column to name, keeping all other columns. So we remind you that we can do this with select. So we want the school column renamed to name. All right, so that'll give us the school column renamed to name, but then we want all of the other columns, so we need everything else. Okay. We can do this with other columns, so we could rename the ethnic group column and keep everything else. All right, so we could select ethnicity equals ethnic group, and then select everything else. Right, that would also work. The disadvantage of this is it's rearranged the columns. So the order of the columns has changed because I've specified the thing I want to rename first. So if I wanted to keep the columns the same order, I would have to first do first pull out the school column, then rename the ethnic group because that was the second column, and then everything to get the others. So it's a bit messy. The rename function is useful in this case, right? So the rename function, because you know renaming is a common operator. Often the way that names come in a data set is often not necessarily useful. They might be too long. They may contain things like spaces, which can be a bit awkward. Or you might want to rename things in order to then chart it. So you might want to be renaming it from a very short name to something that would look good on a chart. You know, lots of options. So rename name equals school, right? But that also then works for ethnicity. right? Because it always gives you all the rows back. So ethnicity equals ethnic group. Okay, then that's renamed to the ethnicity column and still giving me all my columns in the same order. So rename always gives the rest of the columns in the same order. So that's handy. Okay. What about adding new columns? That's what mutate is for. So mutate, change a data set, right? By adding a new column. So all you do is you introduce the name that you want to use and set it equal to what you want to compute. And that could be a source of data from somewhere else potentially. It could be a computation on existing rows, or it could be modifying an existing column. Right, so this first line, let's see what that's doing. We're creating a new column called proportion, which is computed using students, right, this column here, divided by the sum of students. So if you think about what the sum of students will be doing, it'll be adding all of these numbers up, and then we're dividing each of the numbers by the sum. Okay, so it's almost a two-step process. So this is the proportion of students that are in this row. Not a strongly useful thing in terms of useful proportions, right? This 1.26 times 10 to the minus 6, that's just 1 over the number of students in the country, which is like 800,000 or something, right? So thus the just a little bit more than 1/1,000,000th. This, of course, is 2 800,000ths. What about the second one? So when I run this, I get no output. Reason, of course, is that it's an assignment. I've got the equal sign there, or you could have the left arrow sign as well, the assignment operator. And so that's instead created the clean database data set. And if we have a look at clean, then you can see that it's different from the role data in that the level column now, instead of being of character type and having year and then the number, we've just pulled out the number. So if we sort of have a look at what this code is doing, we're creating a new column called level, and because we already have a column called level, we're overwriting it. Okay, so perhaps I could sort of break this down and do new level. So let's so right. So we're creating a new column, and what we're doing is we're taking the level column and we're substringing it with the parameter 6, which is basically, if we look for the help for substring, or Google the help for that, or sort of infer what it might be doing, we can see that it's taking the only from the 6th character in each of the strings here. So basically we're getting rid of the first 5 characters, which is the year and the space. Right, so that code there is just pulling out the number, and then we're converting it to numeric. So again, this is kind of backwards code, right? So we might want to even try perhaps using a pipe, right? We could say level, pipe it into substring with 6. We could even name that. Let's have a look at the substring. First is the parameter. Right, so let's have a look at that. So there, that gives us so essentially we're chopping off the year bit. So it gives us a character column with just the number, and then we could convert it to numeric. So there you go there. And then because we don't want the old level now, because this is more useful to us, we could just use level. Right, and so this is overwriting the level with a new version of it. The advantage of so the reason for doing this is that now level will sort correctly. Okay, if it was prefixed by year, then year 10 would sort in between year 1 and year 2, just because it's sorting it alphabetically, not numerically, right? Because year is a character string. Right, so Right, so that's the other way to do it. I guess we could sort of do it like this, couldn't we? Okay, so let's have a look at some of these other ones. So using the clean data, create a new column, that's mutate, combining ethnic group and level with paste. Right, so we're going to get a new column, let's call it new column, you can call it whatever you like, where we're going to combine ethnic group and level with paste. So we're going to be using the paste command to put together ethnic group and level. Okay, so there's my new column. Perhaps we could call it eth level or something. Right, which pasting these two things together. If we look up the help for paste, I just press F1 on paste. You can see that the default is to use a separator of a space. So we can change that if we like by specifying the separator. Perhaps we might want an underscore, right, and it would do it like that. Whatever you want, right, colon, anything you like. Anything you like will work, right? So perhaps we'll just leave a space. Cool. Okay, what about this next one? We want to do the same thing, but we want to remove the two columns that we've joined together, right? Because presumably now this eth level column is, contains the same data as these. So it's probably least useful, isn't it? Because here we could sort by level and we could sort by ethnic group. We could filter by level separately to ethnic group and so on. That's going to be much harder when things are combined together. We're going to be using string matching or something if you wanted to do year level. But nonetheless, perhaps that's what we want to do. So we could then use select to drop the other two columns, couldn't we? Drop the ethnic group and the level. Okay. We could then also use select to relocate things. So we might want to do something like this. Okay, in order to change the order of things. There's also another handy function you might be interested in. Because reordering columns or relocating columns is is a thing that, essentially what I wanted to do was put the eth level column second, right, after the school column. But in order to do that, I had to type out the school column first, right? So the relocate is handy. So relocate the eth level after the school column. Right? So that's kind of a handy thing to do. Or we could have relocated the students column at the end, for example. So for sort of common operations, there's often a handy helper. You don't have to use the handy helper. You can use the select function, those base functions. Okay, what about this next one? Create a new variable age with the typical age of students at each year level. Okay, so mutate, creating a new column. It's going to be age. Okay, with the typical age of students in each year level. So year 1 students are typically 5 years old, so we're going to take the level and add 4. Okay, so there's the age there. And finally, we could investigate the unite function from tidyr to do what we did in part 1 and 2. So here we were pasting two columns together. So as that's again a common operation, there's a function for it, and that's the unite function. Okay, and you specify the columns, the new column that you want. So this is going to be eth level, and then you specify which columns you're combining, ethnic group and level. Okay, and it automatically gets rid of the other two columns and replaces them with the combined. Again, there's a separator that you can use. Okay, so again, the unite function is just doing those same steps. It's just doing it sort of as a helper, right? It's doing all of those things that we did up in part 2. these steps here, it's doing all at once for us, just because, again, it's a common operation. Okay. Now, this is a bit of a silly one, I suppose, combining these two things together, but there are many operations that are far more useful than this. A common one is with dates. So often you'll get data which will have the date separated out. So you'll have a year column, a month column, and a day column, and you may want a date right from that. So you need to paste those together. Okay. Typically, working with dates, you're constantly pasting them together and then taking them apart again. So if you need to do any modelling, time series modelling or whatever, then you'll need, there'll often be a seasonal term, so you may want to model the months separately. So you want to pull the month out, right? Or there might be a trend where you're modelling through the month by day. You need the day or whatever, right? So there's whenever you're processing dates and times, you're sort of constantly converting from one format to another. And the last sort of main function in dplyr of the sort of the processing functions, so ignoring group by, which we'll look at next, is summarize. So this is for taking multiple rows and reducing them down to one. So this first one is summarizing using the special function in. So the function in is basically returns the number of rows. So there's 66,261 rows. So summarize takes our data set and reduces the number of rows down typically to one. So we're going to get a data set returned which will have just the one row, and in this case we're just going to have the one column called rows. The second one is doing a summarize, right? So we're reducing the number of rows down to one, and the summaries that we're computing is the sum of the students column. So that'll be adding up the total number of students across all rows. So there were 831,038 students in New Zealand schools in 2023. And then we're also going to compute the average, which is the average number of students in each row. Right, so this is a bit of a silly number in that it's the average number of students across school, ethnic group, and level. So on average, there's 12.5 students on average in schools of a particular ethnic group and year level. So not a strongly useful thing, but an interesting computation. Note that we've used we've used a thing that we've already computed within the summarize in the same function, right? So it does the summaries in order. So first of all, it's going to compute the total, and then we can use that total to compute the average. Of course, the average, the mean, is just the sum of the thing divided by how many there are. How many there are is n. Okay. So let's have a look at some perhaps slightly more interesting examples. Find the largest maximum number of students in each row. So this is a summary where we're finding the max students using the max function. So the biggest row is 800. What about the median number of students in each row? So the median function is useful there. Okay, if you're not sure what the function name is, just Google it, right? Finding the median in R. What's the lowest and highest year levels in the data? Well, we could use min and max for that, couldn't we? Min level. Right, so here we have the minimum levels year 1 and the maximum levels year 15. Okay. Now there's another function you could use, which is range. Let's try that just because it might be interesting to see what happens. Okay, so we can see that we get the range 1 to 15, but we also get some output. Okay, and it says warning, returning more or less than one row per summarized group was deprecated in dplyr 1.1.0. Please use reframe instead. So this used to be something that was allowed, if you like, but it was it was felt that it caused too many problems. So the nice thing about summarize is that it forces it to only be one row per group. The reason for that is that I need to know which of these rows, which of the rows mean, right? And so I can infer it from the code, the range. I assume that's going to return the minimum and the maximum. So presumably this is the minimum and this is the maximum. But I have to know something about how the range function works to know that, right? I can sort of, infer probably in this case. But in more complicated cases, it might not be obvious what each row represents. And there's certainly nothing in the output that makes it obvious. So I have to combine the output with the code in order to know what's happening. And that's usually bad practice, right? Ideally, the output itself should be enough to summarize what's happening, which it was, of course, with this one here. I could see that I had the minimum and the maximum. Obviously, I still need context to know what the minimum and maximum are, but I could have encoded that in the name, right? Whereas I can't encode the min and the max here because those are the rows, not the columns. Okay, so typically summarize should only be used to output one row per summary group, right? You'll notice that when I did this, I had it said per group. Okay, and grouping is what we're going to look at next. So let's do this last one. Find the number of Māori students in year 9. So this is a two-stepper, right? First of all, we only want Māori students. All right, so we need the ethnic group equal to Māori. Again, I'm going to copy and paste to get that macron. All right, let's run that, check that it's right. Yep. And then we want only year 9 students. So that's level is 9. Okay. Notice I don't need quotes for the number, of course. So you only need quotes around labels. And then I want to add up the number of students, don't I? And there we go. 17,879 Māori students in year 9. So, the last function to look at is group by, and that allows you to do all of the previous operations that we've done on subgroups of the data simultaneously. So this function here, this line of code here, is grouping by school and then doing a summarize operation. So the summarize operation that we're doing is the sum of the students, so adding up how many students there are in total, but we're doing it by school. So this is going to give us the total number of students for each school. Okay, so instead of the total number of students, we've got the total number of students for each school. So that's handy because then we could, find which is the bigger school, which is the smaller school, and so on. Okay, so let's try some of these. This is really where the power of dplyr comes from, the grouping. How many students of each ethnicity are there? So we want to group by ethnicity. And then again, add up the number of students. So remember, the summarize here is giving us one row per group. So we're going to have 7 rows because we've got 7 groups, and then this is the number of students. Right, so we've got 800,000 odd in total, and this is the breakdown by ethnic group. Which school has the most students in year 13? So we can see that we've got a restriction, year 13, so we only want the rows with year 13, so we're going to do a filter. Okay, to get to just the year level 13s, and then we want to know how many students each school has, so we're going to be grouping by school. Okay, that doesn't change the output yet, right, but it does add the group tag, and now we can do our summarize. All right, so this is the number of year 13 students in each school, and then we could arrange by descending total number of students, and we see that the Correspondence College again is the largest, followed by Hagley College. Okay, and then we can use this to produce charts as well, of course, by first getting the data in the form that we want, right, with our data wrangling stuff, and then using ggplot to do the charting. So here we want to produce a graph of the total number of students by year level. So let's get the total number of students by year level. Right, so we're going to have to group by the level. Right, so that adds the grouping tag, and then we want to summarize total number of students. There they are there. Right, so that's the data that we want. We could then save that and use that in a plot, or we could pipe it directly into ggplot, right? Remembering that the first argument for ggplot is our data. So that's going to give us our empty plot. And then we need to think about the two things that we want on the plot, which is going to be our, we want the year level on the x-axis. In the y-axis, we're going to have the number of students. All right. Notice I've switched to using pluses. Okay, so key thing is as soon as you go from, so use the pipe in your data wrangling chain, as soon as you switch to ggplot, you've got to start using pluses to combine things. Unfortunately, ggplot was created before the pipe came into existence. And so now what geometry do we want? We want a column chart. So there we go. Okay. So we see sort of an interesting behavior where the number of students sort of increases slowly. And then there's this big spike at year 7. And then it's back down again, and we get this tail off as students leave. And of course, very few students stay in year 14 and 15. These are specific schools that have extra programs that run. And so we've got this drop off here. This here is primarily, so my understanding is this is because at year 7, students are recategorized. So depending on when they start school, some schools call some students year 0 versus year 1. So some kids start in year 1 and then they go into a year 1 class the following year because they started perhaps in September or October or whatever. So they haven't had a full year of schooling anyway. So year 1 is technically the first full year of schooling. But if they started, say, in April or March, they've still not had a full year of schooling, but they've had sort of more than half, and so they categorise them as year 1. So, you get different categorisations of student based on when they started. So in year 7, students are reallocated. So that's why we get a bit of a bump there. And the last thing we're going to look at is some missing value stuff. So we'll be looking at this in more detail in week 3, but you'll remember that when we plotted the penguins data before, ggplot informed us that it had removed some missing values. And these are recorded as NA, which is short for not available in R. And that's important when we summarize, right? So if we try and take the penguins data and compute, say, the average flipper length, the mean flipper length, then it gives us not available, tells us that the answer is not available. And that's, of course, because it doesn't have all of the observations, right? There's 2 that aren't available, and if you have two values that aren't available, you can't possibly compute the mean because you don't know what all the numbers are. So adding na.remove equals true to the mean function will fix this, right? So a lot of summary functions like the mean and so on will have a na remove function, and that gets rid of the NAs and then computes the thing that we want. So that's a typical way for missing values to crop up, is when they're already present in the data set. But there's another way that they can show up, and that's when they're implicitly missing. So we might want to try and find the mean number of students by at each year level across schools. Like this is computing, right? So how many students on average does each school have in year 1, for example, and you can see that there's 30 or something. So we've grouped by year level in school, computed the total number of students, then grouped just by year level and computed the mean, right? So this first one will be computing the number of students at year level 1 across all of the schools, and then we're just grouping by year level and computing the mean to get the average. So for the average school, how many are in year 1, right? Now, unfortunately, these numbers are wrong. And the reason these numbers are wrong is because there are no zeros included in this data set, right? So if I did this first command there, and you looked down the students column, there will not be a value that is 0. Yet we know that not every school teaches students of every year level, right? So there's primary schools, for example, only teach year level 1 through 6. Intermediates only teach 7 and 8, and so on, right? So there should be lines in here for the intermediates at year level 1, which should have the number of students equal to 0, but there is not. And that's because they're implicitly missing. They're not present in the data. Okay, and we can see this by just filtering our data set and seeing how often is the number of students 0. And there's no output. That never happens. We can also see it by totaling up the number of students by schools, and you can see that Auckland Girls Grammar only has year 9 through 13 because it's a college, or it's a secondary school. Similarly, Auckland Grammar is a secondary school, and if we have a look through again, there's one in here, the Cathedral Grammar School, that's a primary school. It's an extended primary school that goes from year 1 to year 8. Okay, so we should have zeros in the data set, but there aren't any. Okay, they're implicitly missing. So one way to fix this is to use the complete function. So we'll be looking at this in more detail in week 3, but the idea is that the complete function puts in the NAs. So it makes the implicit missingness explicit. So if we again look at so we run the complete function so that basically all possibilities of level and school are then filled in. So essentially the complete function looks at the options for level and the options for school and just makes sure all possibilities are included. So if you had 3 levels and 4 schools, it would have 3 times 4, 12 rows, right? So here you can see that we now have entries for Auckland Girls Grammar at year level 1 through 8, even though of course they teach no students because they're not a primary school, right? But now we know that they're missing. And of course we can fill them in, right? So we know that they should be 0, so we could rerun the above code by filling in the missingness, right? So if you have a look at the complete function, help for the complete function, you can see that there's this fill argument which takes a list. A named list for each variable supplies a single value to use instead of NA for missing combinations. So there might be here we go, here's an example here. So this is making value 1 equal to 0 if it's missing, and value 2 equal to 99 if it's missing. So let's see if we can do that. So we could go, we want to set the fill equals the students column, set it equal to 0. So now you can see that we filled in the missingness. And now we could compute the means correctly, right? So if we take the code to compute the average number, this one here, and use complete on that, right, so we want to ungroup, and then we want to complete the school level, filling in the number of students equal to 0, right? So that'll give us the correct number of, so we get all possibilities of school and level and the correct number of students. So we've got our zeros in there now. Then we can group by level and compute the mean. And we can see that we have fewer students than before because now we've included the zeros, right? So on average, a school, if you picked a school at random, then on average they would have about 24 or 25 students at each year level, except for year level 7 where they have about 31 due to this weird renumbering. So to finish, I'm just going to knit the document just to make sure it all runs, and so that I've got a record of everything that I've done. So this is going to produce our HTML document with all our code in it and all our output and all our narrative that we've added. Okay, and there it is there. So if we scroll all the way down there, we've got this is the last thing we did there. Okay, we should have a chart up here of our year level.